Hi, good morning, students. Today we will discuss about Earth's magnetism. Uh, though we have learned this theorem when we have discussed about our normal topic in a regular board, but right now we are discussing again that is called as Earth's magnetism. Um, as you are aware about some of the properties of Earth's magnetism, so we will again recall it. Those who were present at that time they will just recall it, and those who were absent they can get this idea about our Earth's magnetism. First of all, let's say I'm putting in front of you one figure that is called as our Earth's magnetic field. How you can just say that up to this point, this is very much beginning part of our chapter's initial portion. Let's say this is the point where you can just say that our Earth's magnetic field is starting from some point and ending at some point. This is the initial introduction you and me at the initial point we are having with. But this is because of what? So very first question toggle in our mind is that why our Earth's magnetism has been produced. So first of all, it is because of the material, or you can say that core of the Earth, which contains so many materials. Because of this material or type of the material, they are our Earth is rotating on its axis. Let's say this is its rotational axis. It is rotating, and this core material, which is made up of some material, is also rotating. So because of that, that changing or spinning of this material, you can say that spinning of the electrons are also producing current, and this current is responsible for the magnetic field B, or you can place that it is also H. So this is the only reason, because of our Earth contains some magnetism. If you look from this point of view, you can see that magnetic field lines are around that Earth in a such a fashion which is shown in the figure appropriately. But very common question is that this is our Earth's north pole and this is our Earth's south pole. So this is my Earth's north pole and south pole, and this is my Earth's east and west part. So these are called as our Earth's geographic parts, geographic poles. But very much common thing we are just aware about is that we think that on the surface of the earth or inside the surface of the earth, that is called as one magnetic field is present, that is because of the earth's magnet, and we are just thinking that there must be a bar magnet. Yes, we are thinking it is a bar magnet, but actually it is not. It is like a crest part. Let's say our earth is like that, and that is called as a molten material, or core part contains some of the material, and because of their motion we can have a spin of electron and current and magnetic field. So this is around 10 to the power 6 or 10 to the power 7 years it has taken to produce current, or you can say in a today life, whatever magnetic field we are enjoying, it is only because of that process of 10 to the power 7 years. Yes, Earth is changing its magnetic field around 10 to the power 7 years, and this is the nature of it. So till today, and next after 10 to the power 7 years, you cannot find it out the same magnetic field of the Earth which you are finding it out today. So what we are thinking is that our north pole of the magnets, Earth's magnet, is over here, and south pole is here, and that is why magnetic field lines are passing from north pole to south pole as per our bar magnet. So this is the direction of our north and south pole. This is the only understanding we are holding till today. But actually what happens that actually this is our north pole, this is our south pole, but these are called as a geographic north. So NG is called as our geographic north, and this is called as our geographic south. So this is our geographic south. This is our equatorial line which is holding that two axes, that is called as east and west. But actually our Earth's magnetic field is because of this magnet which we are thinking which is over here and which is over here. It is not like that. Our Earth's south pole, magnet's south pole is over here, and Earth's magnet's north pole is over here. So in this figure, whatever thing you are just enjoying over here, it is not properly over here, it is somehow tilted over somewhere. So we were thinking that it's passing from here to here, which is not true. So what is true? So the true thing is that our magnetic field lines are passing from this north, because our Earth's magnetic field or magnet is over here, which is bar magnet. So from outside it is passing from the north to south. Okay, and that is why whenever you are putting your magnetic needle, it is indicating magnetic needle's north is over here, because of this Earth's south pole is over here, and that is why we are getting that at magnetic north. So we can have a NM is called as our magnetic north, and that is called as our magnetic south. Sorry, this is called as a magnetic south. That is why SM I am mentioning that. It is called as our magnetic south pole. So we have a two type of poles right now. One is called as a geographic north, geographic south, geographic east, and geographic west. It is called as a equator. But this line, which is called as our Earth's magnetic equator, so I am just putting that magnetic east and magnetic west. So you can just find it out. There is one difference between this Earth's actual north, geographic north, and magnetic north. This angle between actual north and geographic north is called as our declination. This angle is called as a declination. And this declination angle is holding the value 11.3 degrees. You can see that this is the angle, it is called as 11.3, and same is the course whenever you are comparing with our actual Earth's east and magnetic east. Again, you can hold the same thing. So this is how initially we were thinking that whichever north, geographic north, is only the magnetic north and magnetic south as well. But whatever actual thing we have learned in the past is not true. So the true thing is that actual north and magnetic north is holding the angle of between them is called as a declination angle is 11.3 degrees. As far if you are just seeing this figure, you can be very much sure that if you are not taking care of this data, then you might be reaching to the other country as well. You are holding to the Europe and you will reach to the other country like Africa or somewhere else. That is the reason why every person who is holding that magnetic compass must contain such data. Let's say I am putting that this is the angle of declination. Let's say this is my north and this is my south. This is my magnetic north and magnetic south. So let's say this is my magnetic poles and magnetic directions. Now, you can say that there is one more important fact which you have to understand is that there are called as a meridian. Meridian is called as a one type of a plane surface. Let's say I'm putting in front of you this type of figure. Let's say I'm just removing all those data and now putting that for your understanding that uh, let's say this is my Earth, and let's say and this is my north and south, and let's say I'm just considering that one imaginary line or meridian that is called as our geographic meridian. It is like a one pole or like I can say meridian, and this is the one surface plane, and I'm putting that another this is my n dash, so its plane is like that, so its plane is like this one. It means that it will look like if you are holding your textbook, then it will create such type of illusion, and same is the course for your Earth's magnetic and geographic north and like that. So these are the angle between these two things. It is called as the angle of inclination between our actual, let's say this is my plane, geographic plane, so this must be my magnetic plane, so both are holding some angle between them. It is called as a 11.3 degrees. So this is the understanding how you can just represent it. One more thing is that I have mentioned that that is called as a phi. This phi is only for that representation of a geographic meridian and magnetic meridian. Because whenever you are just drawing such type of figure, let's say my magnetic north is over here and magnetic south is here. Miss magnet is over here. This is my magnetic north and this is my magnetic south. You are aware that magnetic field lines are passing like that, starting from north and just ending at a south. But I want that there is a change between the surface, and that change is nothing else. It is a very much important one for me. This angle is called as angle of inclination, and there is one change or angle over here that is called as angle of dip. So you can say that above surface, this angle is called as angle of dip, and that downward it is called as a angle of inclination. Because why I'm just using this word inclination, because it is starting its journey from this surface of the earth, it is called as a horizontal surface, and gradually this angle is keep on increasing. That is why it is called as angle of inclination. And this is ending its journey over here at Earth's magnet south pole. That is why it is called as angle of dip. So this is how you can represent it. One more thing I want to just put in front of you is that let's see. Let's say your if you are putting your bar magnet over here, let's say this is our bar magnets north or south. If it is showing that such type of direction, it means that if your magnetic needle is towards right, its angle must be considered as a positive, and if your magnetic needle at the left hand side, it is considered as a negative delta. So this is the angle representation. You can say that our geographic north is over here and this is our compass north. This is your compass north over here. So if your magnet is showing that angle at the right hand side, it is considered as a positive, and if it is on a left hand side, it is considered as a negative direction. So not every time your angle of declination is 11.3 degree. It is keep on changing as per you are standing at different locations on the earth. One more thing I want to mention over here is that let's say it's components values, and I want to just put that consideration of calculation. Let's say this is the calculation I want to just show in front of you. This is called as my horizontal angle and this is vertical angle. So let's say this is my true north. This is the actual angle which my actual true north is indicating me. Then next one is that that my true east, and this is my magnetic north. So you can say that this is called as a declination angle and this is called as an inclination or angle of dip. So such is the direction. This is called as my horizontal and this is my vertical directions. So these are only the consideration of angles. If you are not comfortable with this, you can just take that angle BV and BH. So we are taking the same type of angle values over here. So first of all, what I am putting is that let's say my values of these angles are like that. First of all, I am putting that B of vertical is equals to B sine theta and B of horizontal, which is called as a B cos theta. So I'm taking the ratio of both. So it would be BB by BH. So it is giving me tan theta. So whenever I want to just find it out angle between angle of dip or something like that, so I can use this formula which is called as my BV by BH. So this is my theta value. One more thing I want to highlight over here is that you are right now aware about the values, which is called as, you can say that my values are like this. Let's say B of V is equals to B sine theta and B of H is equals to B cos theta. So you can say that my theta value is equals to 0 at the poles. Then we can have a B of a vertical component is equals to 0. Or let's say I'm just putting that a theta equals to 90 degree, that is called as an equatorial line. At that time my vertical component is very much maximum. Same is the course for theta equals to 0, and next one is called as a theta equals to 90 degrees. So I can have my component that is called as a horizontal component on the poles is called as a maximum, and it is called as a B of horizontal component will be 0 at the equatorial line. So in 11th science you may have also learned that at the poles and equatorial lines your values of gravity, and at the same time whenever we are putting any satellite into the orbit, these are the components which are very much useful to us. So this is how. One more thing you want to find it out, magnetic field. So you can also use such type of notation that is called as our b1 square means bh square, then b2 square that is called as a v square, twice time of b1 b2 and cos theta. So you can just instead of a 1 and 2 you can include that component of horizontal and vertical. So this is the representation of our Earth's magnetism. It's the components. So very two true thing you want to learn about is that you have to remember three things. Very first thing is that components of horizontal and vertical components of the Earth. Apart with that, that is called as angle of inclination or angle of dip, and third part is called as our declination. So this is how it has been represented as. Now I am putting in front of you one map of the Earth that is called as our geographic map. Apart with that, it is also called as a magnetic map. So right now I am putting that one point over here. So this point is nothing. This point is indicating our Earth's magnetic field is present over here, and there is another magnetic field present over here. So this is our magnets, Earth's magnets North Pole and Earth's magnets South Pole, or you can say that that is this point. This point is also indicating that north, that is called as a magnetic north, and this point is called as our magnetic South Pole. So this is how our Earth's magnetic map can be represented as. So at every point, different point on the Earth, magnetic field is something different, and at every point of the Earth, you can say that it's a angle of dip, angle of inclination is keep on changing. So you can just consider that whenever you are holding your magnetic compass, always keep in mind such type of data.